Hey folks, welcome to today's edition of the .NET Languages and Community Runtime Stand-Up. I'm Chet Husk, and I'm the product manager of the .NET SDK, and I know where the Go Live button is. Today as my co-host and chat moderator, we've got...
Kathleen, I'm the product manager for .NET languages. That's C#, F#, and Visual Basic.
Awesome.
And
we've
I'm
got
Bill
a really
Wagner.
great session for you today because we've got...
Bill Wagner here. I am responsible for all the managed language docs on learn.microsoft.com. So I write most of the stuff on these C# docs with a lot of community help. I do a little bit of editing and reviewing on the F# docs, which are mostly written by the F# community members, and also maintain the VB docs. And I don't even have a Go Live button because I'm in the guest seat today. So,
so like I said, we're super happy to have you here today, Bill, because you're going to show us some new and exciting stuff in C#, either to break us out of the same old that we've been writing for years, or for those of us that are new to C#. So why don't you show us what we're missing?
All right, so let's go ahead and just add the share in. So the topic that I'm talking about, we've introduced at .NET Conf and a couple other things, is what we're calling everyday C#. So this is meant to be the subset of features of the language that almost every C# developer uses almost every day. So almost is doing a fair amount of work in both of those places. It is an intersection of the features, new and old, that are applicable across any workloads, any different scenarios, whether it's high performance, Office forms over data apps, your enterprise apps there, the web services, cloud native, whatever. These are the things that we expect people to be using no matter what they're building. And as Chet says, we're looking at this, and introducing this as a concept for a couple different reasons. One is that we have a natural bias. Most of the people who attend this have been .NET developers for a number of years. So that shouldn't mean, we fall into these habits. There are things that we use, and we have a natural bias to think that the features we've used for years are necessarily easier. It's not always true. We're definitely going to come up with things where, these newer features, we've designed them in LDM to be easier and more natural to use. So we're going to try to encourage you to use them. And so for experienced developers, look at the things we're putting into everyday C# and saying, this is the way we want you to do things now. On the other hand, this doesn't always mean take all of your code and just rewrite it. C# has a very strong commitment to backwards compatibility. So code that works, just leave it where it is. It's fine. But when you're editing or making changes or refactoring, look at starting to sprinkle these in. And, we're trying to break that bias that newer features are more advanced. So we're going to teach people the tried and true tested ways first and then move forward. So, and as a real example, I was working with someone developing some curriculum this week, and as they're looking at the order for teaching C#, they're going, well, I don't want to introduce generics right away. So the first collection I'm going to teach is array list, right? And, anybody here, right, anybody who's using .NET is going, don't do that. Generics or generic collections aren't that hard. They're actually easier to use. So introduce the concept right away, teach people the way they should be doing things now, and then, slowly introduce some of these other things you're going to see. So a few things that I really want to work on here is how should you be looking at some things and some of the features that I really want you to look at. Look at our fundamental section, which I'm going to continue to be updating between now and as C# 13 features start to get introduced. I'm going to be sprinkling these things in here in terms of what are we trying to get people to use? What do we think makes sense for everybody to gravitate toward? Examples that you're already going to see a little bit of is pattern matching. I did a PR recently where I went through all of our samples in the C# guide, and anything that was creating a collection or using a collection as a parameter, it's now using collection expressions. So we really start to dive into those a little bit. That unifies that syntax. If you follow the LDM things closely and look at the collection expressions specification, it is written so that the compiler can make use of as much information as it has about the expressions that you're using to build a collection and write the most efficient code possible. Okay, so as a good example here, I'm going to contrast that with our earlier collection initializers, which is specified that it has to have an add method. So it's going to construct an empty collection and then call add iteratively on every item you want to add to that collection. Well, that has some performance hits, and then it can only be used with certain kinds of collections that have an add, and so on and so forth. Collection expressions, if it's a constant number of elements, it just goes, I'm going to make a collection that big and put them in there. So there's one allocation. Maybe you're using it on a stack and it's a span. I'm going to stack alloc a span for that. And the compiler is free to do the most efficient thing based on the code that you wrote. So you don't have to optimize it. The compiler does. Primary construction or constructors, along with records, are another one that I'm really kind of emphasizing now. If you think of any of the types that you wrote where you didn't want or hid a parameterless constructor, because the only way an object of this type works is if I've got some, I need some parameters, make that a primary constructor, and then every constructor has to go through and initialize that. Records, you get all of the synthesized members that can go through and do value-based equality correctly, along with a good get hash code, a good equal and not equal, and so on, automatic wither support, and so on. So we're trying to emphasize some of these, and then we're just saying these other features maybe you learn a little later. And as you're maintaining more applications that were written a few years ago, you see some of that syntax and you know how it works, but that's not the thing you grab first. So that's kind of the quick overview of what it is. So from that, Chet and Kathleen, let's take it to people with questions and discussions.
Yeah, so let's. I have a couple of comments, and we're looking for questions and comments on this. So the conversation that we want to have is that we've been hearing for a long time things like, there's a lot to learn in C#, and there's because we have this over 20 years of history back to things like ArrayList, and we wanted to find a way that didn't tell you that we knew better than you how to write your code, because we think you know best how to write your code, but it still gave you some guidance and some thoughts and some, what do we think? And it's not like what you should think, it's what we think. And that's the context that we've worked on this. And we've actually talked, about how to present this so that we didn't sound like we were coming off heavy-handed. And the work Bill's done, I think, is great. And it does come down and focus on things that we believe will demonstrably make your code better. And when you include it in your code, that's your world, okay? But that's where we want to start from. And Chet, do we have any questions yet coming up in the chat you want to bring up?
No, but we do have a comment that I could not thumbs up more if I tried.
This is so true. This is so true. Yeah. I bought a new house and I have a 0-turn lawnmower, and I'm learning to drive a 0-turn lawnmower. So yes, in life too. Yes, definitely.
And also, we've got some folks that are already enjoying the type matching syntax.
Oh yeah, that's definitely one of the ones that this is another thing that we're doing in Docs, meant to address that bias. If you look at a lot of our samples, what you're going to see over the next few years is we're going to slowly upgrade any of them, or when we upgrade any of them, we're going to basically just be refactoring and sprinkling in the new syntax. We're not necessarily going to explain it every time. We're just going to start adding those things, whether it's the type parameters. You saw an effort we did a few years ago where we did the same thing with a lot of our samples are, do some manipulation and write the values of some objects. And we replaced pretty much all of the string.format calls that use positional syntax with string interpolation, right? And the reason we did that is we want developers to see it more often, because then it'll become more familiar. Moving against that implicit bias that, I've seen this, I know how it works, so I haven't seen these new things. And turns out, in that instance, it was definitely more readable. I can read the value of this variable is, this variable, rather than the value of this variable is bracket 0, comma, this variable, and especially when we have more of them in there. And we're going to do the same kinds of things with the newer features. Another one you'll see coming up, we're going to, any number of samples have text that represents JSON data, in our JSON serialization docs. We're going to be using raw string literals there, the triple quoted strings, because then it's just easier to just read the JSON because it looks like JSON instead of backtick quote, and so on everywhere. So we're going to be doing those kinds of things as well.
Yeah.
That's something that I sometimes forget about. Like what you're touching on here is that like the language evolves, but there's this whole like surrounding set of samples and documentation, and like even you can go out as far as like Stack Overflow answers that sort of accrue the old patterns that we have to be on top of updating. So like really the work that you and your team do is like unspeakably valuable.
So, and this gets into some of our AI stuff as well. This is something we refer to as the Stack Overflow problem. And again, an example from a few years back is if you were asked and went to Stack Overflow and said, how do I make sure that an event handler is thread safe and, doesn't get detached before I invoke the event? It would say assign the event handler to a temp, and temp equals this dot some event. If temp doesn't equal null, then invoke it, right? And since C# 6, the Elvis operator, temp event dot invoke is a much better way to do it. But there was already 15 years of upvotes on the original answer. So we're fighting to get. Fighting might not be the right word, but we're definitely pushing to get the newer syntax seen more often. And by doing that, then anything that's training AI models on, say GitHub samples, we know that our doc samples are used as training data for any number of, our own co-pilots and probably others as well. So we're pushing faster than I would actually recommend people with production code to do. And that is because our samples have a different purpose than your business app, right? They're meant to be learning materials. So there's, we don't have that, there's a release tomorrow or this week, whatever you do, don't change any code in this big app. And again, the purpose of the sample is for people to learn. So spending our time making the code something people can learn from is valuable time for our team.
Yeah, absolutely, yeah. And that problem is even worse with F#, by the way, because Stack Overflow was there when F# was first starting, and in its early stages, there was no Stack Overflow in 2000. That's still, there were other tools, but they're gone. So the initial push for C# has been lost, and we don't see that. But Stack Overflow did start like 2008 or something, and so we go back into a lot of things around threading and tasks, and that whole entire space is very fraught on Stack Overflow, and there's not a good answer for it for us. But back to everyday C#.
Sure.
And where we're going.
So yeah, any other questions? Or I'll ask one for people to add comments to if we don't have one.
We have a couple of things. There's one, I'm going to show one that I just want to give a shout out to because it's one of my babies, is that if you want to work with Jupyter and VS Code, you probably want to be using polyglot notebooks because that extension gives you C#. The C#, there's a lot of complexity in the kernels, and so there's ways you can use a C# kernel not in polyglot notebooks, but it's the easiest way to do it. So I just want to give a quick shout out on that one. And I don't know what Chet's spotted in there that he might want to bring out. There's some good conversation in there, but we just want to bring out stuff that's relevant to this.
I want to shout out Riddle time here for already updating their projects to .NET 8 so they can take advantage of some of the things that Bill's going to show off today.
Yeah.
Everybody should go do that.
Yes. And for y'all that don't know this, I just want to also say that when you pick a TFM, when you pick the .NET version, so the target framework, which we tend to call TFM, I'll try to say target framework. When you set that to a new .NET version, that also updates by default your language version. So that would update you to C# 12 or to F# 8 right now when you go to .NET 8. You can downgrade your C#. That is supported. Upgrading to a higher version is not supported, but is done by some people. So you can split them, but by default, that's how you get C# 12 is to target .NET 8.
Yeah, if you use the newer language version, there be dragons. You really need to read the spec carefully to understand what happens.
Yes. Some things work, some things won't is the short answer. And so, if you're in .NET Standard or .NET Framework, then it's definitely a fraught problem. Yes.
Yeah. And one of my big questions for this audience, since I know it's people who are already really engaged with .NET, I've got I'm going to slide back here and I'll pop this one up. There we go. I've got a tentative project in terms of what I think is the set of features for everyday C#. And part of that is what things I think I want to leave out and possibly, and say, these are still important, but I want to cover them later. And I definitely continue to want feedback on that. As we've gone forward, I see things like, we're even splitting some features in there. Like I think for async and await, I think some basics are needed in everyday C# because so many of our APIs now support asynchronous versions of them. But some of the more complicated scenarios, like how do I start 6 or 7 tasks and see which one finished first? How do I cancel tasks when one thing finished and I don't need the results of others? Some of those we're pushing into its own section on dedicated to asynchronous programming. But just the basics of how to handle async and await, I think, is something every programmer now needs. We have a similar discussion around arrays in that it's kind of the most common collection, but yet we usually have better ones. So we're kind of still discussing that one a little bit. And then things like top level statements is one that generates a fair amount of controversy. My own view at the moment is I think it is a great way to start. And I think there's a lot of good things you can do with top level statements. But I do realize that's one that's caused a fair amount of controversy with some folks.
Yeah.
So.
Yes. Yeah. So one of the things I just wanted to say, one thing on async, one of the interesting things there is that it's one of the few places where the platform you're working on massively impacts your experience. So for example, if you're in ASP.NET, then you need to understand this notion of async being viral. That you have the pipes in your house are viral. Okay, it's the same thing. It says you have to pipe it all the way down and all the way back. But once you do that, all the hard work is done by ASP.NET, and all you had to do was make your stuff async. It's very little work, and it works great. There's a few things you can run into if you actually need to multi-thread instead of just async. But if you're in WinForms, there's some things you can do that are fairly easy. But then there's other things that you can get into that are actually fairly complicated. And if you don't understand what you're doing, there is a lot of code in the world where async was added to speed it up, except it actually slowed it down. We can look at this bad code and go, oh, well, you're creating a thread and then waiting for it, and that does not help you. It's really interesting, as Bill looks in the challenges of getting async documented well, is that there are certain scenarios where you need to understand almost nothing about how it actually works. You just need to use it, and that's WinForms in events and ASP.NET, and other places where if you don't understand it, you will run into foot gun problems where you can shoot. So But Bill is great at doing that. And can you bring back up your resources slide for just a second? Because I want to shout out to something on that resources slide.
You do that.
So we did something for .NET. It was in full fruition for .NET 8. We've been working on it for a couple of years, and it's way harder than it sounds, okay? Is that we have altered the way that we do the What's New page to do it in real time during previews. So if you went back to like .NET 6, Bill picked it up in September, October, and he said, oh, now I know what it's going to look like. Let me madly try to get all the docs in place. And this is a problem on so many levels, including that the team's now thinking about other things, and so they're not as responsive. And so now Bill is more integrated with the design and is starting to document during the previews. And so we don't promise to be exactly at each preview, but very shortly after each preview, we'll have the features new to that preview that are documented. And I really want to take my hat off to Bill and the other folks that have been involved in smoothing out our communications pipeline to make that happen for you.
That's so great.
Yeah. I'm also going to give a shout out to Julian and others on the compiler team. So one of the big things that's now changed there is when a feature gets merged into the main branch in the Roslyn repo, I get notified. So in terms of adding the docs there, then I do know when it's going to hit public preview, and then I can start working on things. And included in that PR is any of the new compiler error messages that show up because of some new feature. So 12 is the first version where all of the new compiler messages added between 11 and 12 have F1 help. So it will go somewhere other than, sorry, we don't have information on this one. And while that sounds easy, that's a much harder problem than it started with, especially before really getting that kind of, here's the PR and here's what's changed information, because a new release might add like 100 or more messages, and you're trying to wade through those, and it's just, you can't find them and can't build something around them well. So that's probably a big shout out. And by getting there earlier, I basically can integrate every place where a feature looks like it will work, and where I need to update and try to catch all those places. Still not perfect. And again, I really appreciate the community members who find places I missed adding something. And that helps. I think we're doing really well there, though. I think we're getting much closer.
Which I do want to put a shout out in there, like the .NET Docs repo that Bill is talking about and has links to right here. That's all open source. So you can see everything that he's doing in advance of each preview. Mm-hmm. And if you find gaps, you can submit issues. And if you want to take a stab at it, you can document things, and he and the rest of the team will help you get that in.
Yeah, and as far as that goes, I was going to say two really good things there. If you're on any given article, at the bottom of the page is a link just to say open a docs issue, and that routes you into one of our templates, which gives us a little bit more information. So you don't have to say, what doc it is and so on and so forth. And then we'll be looking at those pretty quickly. And then, there's also help wanted issues. If you want help, grab something and give us a PR.
And for an awful lot of issues, there's also an edit button. And so if you ask to edit an article, then you go to GitHub, and you have to push edit again. Sorry about that. But then when you do that, you can actually, like, if there's a grammar fix and you just want to say it's easier to do it than it is to explain what's wrong and where it is in the document, just go do that. It's going to be a normal PR. Bill will review it. You're not going to make a mistake and mess anything up. If you're not sure, you can just make a note in the PR that you're not sure about it, but you want to show something as an alternative. That's all good. So we really do encourage. We're open source, top. We try to be pretty much top to bottom. Yeah. And so the docs is definitely an open source thing.
And there I'd say for folks here, use your judgment. I tell people this if they write issues or PRs. If it's, as Kathleen says, if it's a small typo or rewording some things, then put some things in. It's almost easier to describe it in a PR than going in the fourth paragraph, the third sentence. This word should be highlighted differently. But if you're going to put in the amount of work to write a new document, then write an issue first and give us a paragraph about what you want to do, because we don't want to waste your time either. And have something really big show up and then go, yeah, we're not going to take this.
Yep.
So,
Yeah.
use your judgment, and it usually works out pretty well. And thank you, Kevin. I don't think I recognize, I don't know what your GitHub ID is. I may not recognize that one, but I know others on my team also review PRs every day.
Yeah, it's huge, effort on docs. There's many people that are involved. So depending on where it was, it might have been somebody else that did it, but it's actually pretty easy to do. And it's if you're interested in becoming an MVP or something, it's definitely an open source contribution when they look at that. So it's kind of an easy way to help us out. But what Bill said about open source in general is if you have something big, talk to the maintainers first. To make sure that you're in alignment with what they're doing, and obviously this is writing, and so first drafts don't immediately show up in the repo. So Bill's going to do some work, and so you don't know whether that a bad article is already being worked on. So definitely, if you like this whole thing needs to be rewritten, then let us know first before you do that. So,
well, and the flip side of that is once you've talked to us, if you're writing something, create a draft PR and say, can you give this just a first read? Yeah, it looks like you're heading in the right direction. Here's some things I do to clean it up. And that also helps us give review comments that match where you think the article is.
Absolutely. Absolutely. Yeah, there's a thing that we use. I learned from Matt Torgerson about like giving a 30, 70, 90% on something. It's like, these are just my ideas. And you can use this on any document you're working on. But tell your reviewers, kind of like, I just want to see if my idea is right. I kind of want to see if my structure of the doc is right. I'm finishing this thing up. Can you please help me with grammar? And if you're not in alignment with your reviewers on that, this is just like that's a life tip. Hey, so Chet, what do we have in the chat? Do we have anything there that's up? I know there's a question on C# 13. I'm a little unclear what it is. If it's just a release date, we can give you that. But yeah.
Well, there's lots of love just in general for the docs. There was one I especially wanted to shout out. Like, folks appreciate the work that goes into making those compiler messages.
I think Jason has even submitted some PRs to help us in the past there too.
Yeah, I know.
This is Jason right now.
Yeah.
Yeah. Some of us know Jason, so yeah. So there's a question on C# 13. I don't know if you want to bring one of those up, but one of them is C# 13 coming out soon? C# 13 will come out next November. We are on a clear 1-year cadence now. And so you can see that probably right around the second week in November. We don't have a date in November, but it should be November or very close to it. It's been November. So that'll come out with .NET 9, C# 13. And for people who recall that we skipped Visual Studio 13, that was actually for an unrelated issue, not a fear of the number 13. And so we will be on C# 13 and F# 9.
Yep.
Like clockwork.
Yeah. Yeah. So cool. Bill, what else do you want to show us?
Well, the main one I would go through in terms of any features, we kind of alluded to this one, is I do want to discuss a little bit of why we're looking at some of the new collection expressions. I think provides a great working set as to why are we encouraging some new ways to do things? Why do we want to push some of these new features? And here, this is a few of the things of how collection expressions work in terms of how something is going to happen and why we put this together. So if you look at this, I've got this write byte array method that's overloaded with span a byte or an array of bytes. Okay. Now, if you look at how this is put together, this is going to, when you use a collection expression, that not overloads, different methods, the expression can be different types, right? So a collection expression doesn't have a type, but it is convertible to any of the collection types that we have. Broadly speaking, there's some detailed rules here. But so if you put something inside the square brackets, that thing can become an expression and it can be turned into some kind of collection. Okay. So we can, It's an array. Okay, fine. It can be an empty array. Here, this is going to be an array of bytes. The next one is a span of bytes, because we're converting it to a span of date time, because we're converting it to a span of date time. And here where I create a collection of bytes, and I'm calling write byte span, that's going to be converted into a span of bytes. And if you look here, this list of int, this is the classic syntax, right? So what that is going to do is it's going to create a new list, 0 elements in it, and then it's going to call add. Now, in this instance, it's probably not a big deal, right? Because the first add is going to allocate, I think, 16 elements or whatever it is, and then there's no more allocations. But if it were a big thing, then you're going to be repeatedly, allocating, copying, allocating, and copying. And if you look, we even have IntelliSense now to say, I want to use the new collection expression syntax. This does the same thing, but now the compiler is free to say, I know there are exactly 4 elements here. I am going to create a list and initialize it to a capacity of 4 and then put these things in it. Okay. And that can work even further along down here with the array. We're now enumerating 2 things. Those 2 things may, in this instance, they happen to be arrays. So the compiler knows how big the array is, or can generate code to say, what is the length of this array, and knows that more numbers can be allocated to say, this is going to be an array of 9 things. So I can already allocate it. I don't have to make temporary storage, and I'll put the contents into it. Right. If this were something that was IEnumerable, it could do some other code, possibly see, okay, it's an IEnumerable. Does it have a way I can get its size and then allocate the right thing and put stuff into it? So the compiler is free to do any number of code generation actions here to generate the most efficient code. And what's most important is if I go back to my earlier syntax here, depending on what kind of collection you were trying to initialize before, you had to remember, is it square brackets? Is it curly braces? What's the expression that goes in? Do I have to new it up? Do I just initialize it? What do I do? Collection expressions are now one unified syntax. If I have a collection or an argument that must be a collection or an enumerable, put it in square brackets, and that works everywhere, right? So that's why we're pushing that kind of syntax into the everyday C# thing. Our hope is as people see it more and more, it's going to become more common. A bit of an anecdote on this is when I first did update all the collection samples, for the next 2 weeks, I would probably get 1 docs issue per day that was, this sample is wrong. That should be curly braces, not square braces. And, I'd respond and close the issue and say what feature it was. And then people would go, oh, that's cool. Okay. So it is starting to do the things that we want to get people to see this a little bit more often. And I think that's one of the big ones that we're really looking at. Another one.
So
yeah,
we do have a couple questions about it.
All right, let's do it.
Can I say something first about this? Because I want to clarify one thing. Just you said this, but I want to make sure it's clear. Okay. So early on, you said a collection expression kind of becoming, and I want to be really clear that this is a compile time issue. This is syntax, and the compiler looks at your syntax and does what's called target typing. So it looks at where it's going and it decides what it needs. And this is all at compile time, which is why it can be so specific. And if you want to go into Sharp Lab or something, you can find this, you can see how specific it can be. We also have there's a productivity issue that's showing on screen right now, which I can ask you to fix if you want to, Bill, because I bet you did this with the productivity update and you don't need those bytes because the byte array is expected, so you can target type byte, so you can yank that out and it looks even prettier. So this illustrates what we mean by target typing, is that we don't need that part, and it's all just like, I know you want an array of, or whatever bytes, array or list, whatever it is of bytes that we're doing, so we're just going to go grab that. We're going to make exactly what you want. And so for IEnumerable, we make something special that is, it's kind of a hidden thing. We do a funny thing with IEnumerable, but it will work in all the ways you want IEnumerable to work. So you don't have to worry about that. But this feature looks so easy. But this was this is what I call swan dive, which is a very simple thing that's actually very hard to do perfectly, really well, not perfectly, but really well.
So we've got a constellation of comments and questions around this feature that I think we can sort of set up and knock down. So first off, I love this. This for me is my like MVP feature for C# 12. It really does just sort of substantially change the way you write the language. There are some questions about the capabilities of it. So first off, Alex L says, I would love it if it could be used with var and take read-only list implementations and that sort of thing. Do you have any comments about how this interacts with var and how people should think about like when to var and when to explicitly?
So we would love to have it work with var. Okay. So I used the term natural type there before. So if I just write without any kind of context, that open bracket 1, 2, 3, what type should it be? So if you think of other areas, there's a natural type or there's an obvious type, right? Var I equals 5, it's an int. Okay. It could be a byte, could be a long, but the natural type is int. Okay. Now, the problem for var and collection expressions is there are 3 really good candidates for the natural type. One is span of whatever it is, because that's going to be the most efficient, right? Depending on how you use it. One is array because, well, it feels right, and there's already language support that's specialized for arrays and so on. That feels right. And one is list of whatever you wanted because you're creating a collection and you probably want to do collection-like things with it. And so far in LDM, we really haven't figured out which one of those is best and which one harms you the least, in that. For instance, if we pick array, okay, great. We had to do an allocation. Well, we could have avoided that allocation if it was a span. If we pick span, well, what if you want to use it in a place where you can't use a span? Then it wouldn't work. You can't use var. If if we pick array or span, then it's already a fixed size. You couldn't use a collection expression and then add more elements in another operation. So there's downfalls to each of them, and we don't have a good way to fix that yet.
And can I say what the problem with list? Because I think it's really important how we thought about this feature. List is heavier. It will be it will not be the most performant thing, and all of the work that the compiler team is doing to make your life easier. We have this overarching passion that making your life easier should not make your code slower. Right. And so we have this deep passion for that. And so when you look at like array versus list as the easy argument, the people who want array not list are saying, but list will be slower. We will slow people's code down. It will be slower. It will be faster to not use var. And so this is because we don't want you to look at every single simplifying feature we have and ask yourself, will it slow my code down? We want you to be able to say, hey, I trust him. And so we're really, really working on building that confidence. And that's why this is a hard decision. And if we can't make it, we won't have a var. And you'll survive because maybe you have to tell us. Maybe target typing is that important. Not everybody agrees with that position either, by the way. So,
right. There's good reasons on both sides. Yeah. And so then the other one, I read only list. I may defer to Kathleen a little bit on this, but in general, I would think,
I don't know the reason it doesn't work today. Yeah, I do.
It's the immutable collection add thing. Okay, I
don't know that. I don't know the answer to that. That one sounds easier because there's a read-only list, and why wouldn't we use read-only list for our read-only list? Because I know we had a philosophical belief that was probably a good idea.
Again, getting back to the optimizations, we're trying to write the most efficient code we can. And if you think about when you build a read-only collection, there's a helper class that usually does the building. So you can build everything in a mutable thing and then say, now it's the thing. Now it's the immutable read-only thing I want. And that's good. Now, the other thing then is you would be copying this every time you wanted to mutate it. So we want to be both efficient and have some kind of a pattern so that for anybody's read-only collection, we make it work correctly. So that is a worthwhile but interesting problem.
Yes.
So
Speaking of worthwhile and interesting problems, sort of the next follow-on comment here is Stefan saw, I think earlier, how you had annotated 1, 2, 3, and so on with byte, like explicit
yes,
coercion operators. And then Kathleen showed how that wasn't necessary in this iteration of the tooling. Is there some place that folks that are interested can go to get a better, or to develop their intuition for what the rules are here? Because there's obviously like target typing of the collection expression to the member parameter. But even that in C# is kind of a complicated question. Like, how do you go from int to byte? How do you know that's safe, etc.?
Right. So it's complicated. The really short version, and I probably need to update some of the docs if it's not on the language reference for collection expressions, is if you think of a collection expression, it has a combination of elements and possibly spread operators. Okay. So let's start with just elements. What the compiler is going to figure out is what is the best common type of all those elements. So, oh, well, they're all strings. Well, my collection expression is going to be a collection of strings. If they're all numbers, it's probably ints. They're all integer numbers. If they have decimal point in them, it will probably be decimal because that's, or I mean, excuse me, probably double because, 1.2.3 is a decimal, or is a float, or excuse me, it's a double. And then if everything is convertible to double, that's the best common type. Similarly, you can extend that if you have some interfaces types in there and some, objects or whatever, it may end up being a collection of object. Yeah.
Does that apply to target types or just natural types? What you're saying is absolutely true with natural.
No, that's gonna apply to what it can be converted to, right?
Okay.
So it's gonna be basically a collection or a sequence of some type, right? For 1T. So like a collection expression can be, this is a collection of integers and floating point numbers. It's going to be a collection of doubles, right? So it's going to look at all of the elements and go, what is the best common type of all those elements? And then from there, then it's like, okay, I've got a collection of those things, and it should be convertible pretty much to just about any collection type. There's right now, they all have to be sequence collections. We have a feature request to support dictionaries, key value pairs. We haven't implemented that yet because we're still discussing exactly how the syntax should work and some things there. And how the semantics should work as well.
Yeah.
But so yeah, that's probably the best. I'll take a review over what I wrote because I'd like it to be easier to read than the spec, to kind of go through what I went there and describing. Okay, so inside those square brackets, what is the T that is the type of that collection, and make sure that that's clear.
Yeah. So I would give another answer, a pragmatic answer, which is go do the use the fixer. Say, you've got something and it's not currently collection expression. Use the fixer into collection expression. And then if it gives you a type like that byte, just yank him out and see if it still works.
Yeah.
Because the compiler is going to tell you. If you're broken, it's going to tell you. And so from a pragmatic point of view, we work really hard on the productivity things, leading you down the right path and helping you along. And I don't know why that byte is left in there. I haven't talked to the team to find out.
I also may have written that code for that sample during a preview.
No, I've done that. I know that's what the productivity fix does right now, is it does leave byte in there today.
Okay.
So I'm not quite sure why it's doing that. And it could be because you had it there before and it's hesitant to take out your explicit typing. And that's an understandable point of view. So because it would have to know that it didn't need that anymore. But yeah, I'm not quite sure what that particular story is, but yeah. We love
Okay.
this feature. We worked really hard on this feature because we loved it so much, and we want to use it everywhere. It's like I
So
never
speaking of using it everywhere, that was like the perfect setup because Scode from Twitch has a question sort of about the future of the feature.
Okay.
He wants to hear more about using this for params.
Boy, am I glad you asked that. And yes, we think that's a great idea. So
well,
what's
yes.
that?
Well, we definitely think it's a good idea to use the technology we developed for this. Okay, but this is the collection expression, like explicit collection expression has square brackets, and in params you wouldn't really need the square brackets. So it's the underlying, all the underlying typing, but doing that against params. And yes, we're working on that, and we talked about it in the language design meeting this week, so you can check those notes if you like.
Mm-hmm.
Oh, which we should also mention, there are some small changes. Particularly, it's in the language design notes this week, but there will be some small breaking changes in collection expressions that will be coming out probably in the version after January, probably, I guess that's March, the next version of Visual Studio. There are little tweaks that are very niche. We think it'll affect very few people, but when we do a new big feature like this, sometimes we go, oh, we made a mistake and we don't want to have to live with it forever. So for the first like 6 months, we do give ourselves a little extra leeway for breaking changes, just to let you know. We don't think it's going to affect very many people, but that is going to be coming, and it's in the language design notes this week.
Yeah.
Sweet. And the language design notes that Kathleen and Bill have been referencing are linked from the proposal that I put in the chat. So you can go to that page and you can find the design meetings and working group meetings sections there and read to your heart's content.
You can also say C# LDM or language design meetings, and it should take you to the right. It's in our repo on C# Lang. Everything's on C# Lang. All of our design work is GitHub C# Lang with C# as CSHARP LANG, one word.
Sweet.
Yeah.
Well, that's all of the questions that we have around collection expressions specifically.
Okay.
So with that, I will, let's see. I think we got time for this.
And somebody says, can you show some examples? But I'm not clear what they want examples of.
Well, I was going to show one more
examples
thing.
Would be great.
Yeah. So I'm going to switch over to Sharp Lab here because it works nice there. Here we go. So this is where I want to talk about records a little bit, which is the other thing we're kind of pushing as a type and as a way to think about records, which is also something I'm adding and doing a little bit more work updating docs. So here I have a class with a person using the required keyword for first name and last name because everybody has a name. We've got getters and setters for age and for a date only for a birthday. And we've got a certain amount of code that's been generated here. Sorry. Okay. And now where I want to talk about this in terms of records is if I right up here add the record modifier, let's Sharp Lab do its thing. Now there are a few interesting things that have happened. Okay, I've now got a compiler generated equality contract that says what type this is. I have now got some things down here. I've got an override of toString and an override, protected override virtual function for print members that builds a nice quality toString method that says, here's all the properties of this type. And since this is virtual, I'm going to return true. And if you look at what happens here in the override of toString, it says, this is our type. And now I'm going to call the print members using that string builder. And then I'm going to append the closing stuff. And that's what it is. The reason it's generated this rather complicated part is because I didn't seal this class. You could derive like an employee or student or professor or whatever from person. And I'll show what seal does a bit different later. We have the operator equal, operator not equals. We have a get hash code. We have an override of equals, which now returns the correct equals based on this type. We have a compiler generated clone to create a copy constructor. And then we also hide the default constructor. Okay, now if I add sealed over here, it's going to change a little bit of what happens around some of the functions in terms of now I just have the string and now I have a private print members because I can't derive something different from this and have different things inside it. And now if I go back, we'll make it just a record. Now let's change it again completely. And now if I make this a struct, okay, now we do pretty much the same thing with just struct, but now you're on your own as to how you want to implement equality and such. System.value type has some default behavior that uses reflection and does some bits there. But what we can do, because I want value-based equality, is if I turn this into a record, it's a record struct. It implements that I equatable. And now, because structs don't have inheritance, some of these members aren't going to be virtual and so on, but I now have an override of toString that does exactly what we want. We're going to make a print members basically because it really doesn't hurt and it's consistent. And the JIT can recognize this pattern and optimize some things as well. We have a operator not equal, an operator equal, an override of get hash code, an override of equals, and automatically you're going to get built in that wither support. So again, what we do with records here is we're basically going, we know what you meant because you're saying, I want to do value-based equality here. So generate all the correct things to do value-based equality, right? So now you don't have to worry about, did I miss one of the members? If somebody comes in later and adds a new property, is that property participate in equality or did they forget to add it? Can I use this as a key in a dictionary? Does its hash code method do something reasonable? In all of those areas, right? So all of that gets done correctly for you and generated by the compiler just by saying, make this a record. I want value-based equality. Now there's other optional features you can add where you can use primary constructors to generate init-only properties and to automatically generate the properties inside your record. You can force mutability if you want. You know, I could change all those properties to get only and then force people to set them through a constructor. and so on. So the idea here is, once again, we know it's a common pattern to say, I want this type to behave like a data object. It should have value-based equality. Please synthesize all the code in that's necessary. And I sort of alluded to the fact that the JIT recognizes the pattern that's done by this. So some of the optimizations that can happen actually don't happen in the C# compiler, but happen in the jitter. And because the compiler is generating this code, the JIT recognizes, oh, this is the code that's generated for a record. It recognizes that pattern. And if it's doing either, I know there are no derived classes from this, or I know there is no, this thing is sealed. I can maybe inline this or do something to speed it up because it recognizes a very consistent code generation from the compiler. So that's one of the reasons why we're pushing these kinds of things to say, use the new features to do these patterns, because the compiler will generate code that the JIT, when optimizations are can be fruitful, the JIT will recognize that pattern and be able to do some things with it. So
that's awesome. Can I add two quick things?
You can.
First of all, for anyone who has not seen SharpLab before, what you're looking at on screen right there is the code that Bill wrote is on the left, and then it was turned into IO, and SharpLab then decompiled it back into C# so we can see what the IO actually does. So that's what you're actually looking at here. And I can summarize a lot of what Bill said, which was awesome, and it gave you the reason this is true, but we're not quite sure why you would use a struct instead of a record struct. If you really want to handcraft those, because you know more about your struct, then we could possibly know. So, for example, it's got 100 fields, but it will always be fully identifiable by 3 of them. Sure, use a struct. But even then, you can just override certain methods in a record struct. Right. So yeah, so it's pretty. We really think record structs, classes. It's whether or not you should be using records on classes is a little bit more of a what are you trying to accomplish kind of question. Yeah, it's a more of a difference.
That's probably one thing I did gloss over is the compiler generates these methods only if you didn't already write them. Yeah. So you could write your own equals, your own git hash code and so on. And I agree with Dario, writing git hash code manually is definitely pretty terrible. It's also very hard to get right in the general case. And that may be one, if you have very specific needs, you might want to override. Like maybe the subset of integer values on this field is always between 0 and 5. So I want to, do something with just 5 buckets, whatever, kind of making it up very shortly. But you may find, because you know something about the distribution of certain properties, that you can do better. But that's definitely an advanced proposition.
And a rare one.
Yeah.
Awesome. That was awesome. And you can also go into Sharp Lab if you want to find out more about what collection expressions are actually doing, the code that's actually being created. So if you are curious about a thing, and there's some extra code in there, I'm not quite sure why it's there, but I trust the people who did it, and I'm sure it needs to be there. So yeah.
So just as that example quick, we can just run up really quickly.
Okay.
Here we go.
Great example.
And there's what it does.
And then if that's a list, so if it's an array, you might say it's not that surprising that it gave the length of an array, because that makes sense. But lists, generally, we don't think about defining a size on, but because it is defined here, then it's more efficient, significantly more efficient, and you just don't have the imports. So yeah, we'll get it. Yeah. All right. So then you can see that the down there and exactly why it does it, builds a span and then adds to the span. I don't know, but really smart people did this stuff, and I'm sure it's done as fast as it can be. Because we have people that are extremely deep into how to make this stuff fast.
Yeah. I will say, when you're using Sharp Lab, one thing you have to be aware of is that you are reversing IL. And so the C# you see may not be exactly what was written, right? And so this pattern that we see of num plus might not be the way that the compiler is admitting that. It's just the way it's being interpreted. So allow a little bit of leeway there.
Sure, that's true. That's a really good point. Yeah, great.
Yeah.
All right, so we must be getting short on time.
Yeah.
Any final questions? There's just a couple comments to follow up on, and let me know if you can hear stuff in the background, and I'll mute myself again. Coming back to collection expressions.
Yes, we can hear stuff in the background. Can you put it up, and Bill and I'll handle it, because that vacuum is obnoxious. Okay.
Oh. Yeah.
Go, Bill.
Well, since we're here, I'll sort of type this, because I think this just won't compile. Let's see if I word it.
Well, collection expressions aren't gonna work with a var. So
yeah, I know, but I'm also just going, we don't even know what type this might be.
Right. And also, if that was a list of anything but object, you would get an error on the member that wasn't correct. So that should be fine.
That works.
If you change object to int, then today we'll give you an error. It's just normal code.
That'll work too.
Yeah. Oh, don't use dynamic. I'm sorry. No, I just have a bias. It's a personal problem.
Right. So that was basically what we were looking at there, is just what is it convertible to? But like if I were to do, let's see, if I were to do this, and of course today doesn't work, but I can now do 1.23, but I can't do 4.5 M.
Yep. Great. And was there another one? Chet, you want to put up anything else we've got? Just keep putting them up and we'll keep answering them and then we'll be done when we're done. Can we have a tool in VS to know what the compiler generates? I don't know, maybe, but we pick the most important things that we think for you to do, and SharpLab is out there, and the only downside to SharpLab is you are sending your code over the internet. So if it's your secret, don't put your secret sauce into SharpLab, but for just understanding how things work, it's pretty good. You're welcome to put a comment in Visual Studio has the feedback button, and that'd be a great place to get that in the Visual Studio team. We're actually not the Visual Studio team. So yeah. And there's also, you also probably, if not, we should be able to do that in Polyglot Notebooks. And if that ever makes it in Visual Studio, some sort of a .NET Interactive, then you could do it through that. So that would be more of a general purpose, like all this kind of stuff that's out there, we might be able to do, but yeah.
Yep.
So Chet, how are we doing? Do we have anything else, or is it ready to close out? And with your vacuum, either Bill or I will close out when it's time to go. Okay. Do you want to close out, Bill, or do you want me to?
I'm all good. I would just say, definitely write any issues somewhere in our fundamentals area. If there's, or in any of the issues that are in the Everyday C# project, I'll pop that page back up.
All right.
And if there's features that you really, really think belong in this subset, or features that you really, really strongly think shouldn't, I'll take that under advisement. I'm not going to guarantee I do what everybody asks, because I am trying to get input from a lot of different places. Watch as we keep putting some of those things together.
Yeah. And I'll close out by saying that we are very, very happy with the C# 12, F# 8, and .NET 8 release. We're super excited about it. And so if you haven't downloaded the latest, we hope that you will. And most people get that through, many people get that through updating Visual Studio. So if you're a VS user, just update your Visual Studio. If you're a VS Code user, you can update the .NET SDK. And we're pretty happy with it. So yeah. All right, and we're just gonna let Chet wave because we don't want to hear his cleaning folks vacuum. So unless there's anything else, Bill, let's say goodbye.
Yeah. Goodbye, everyone. Thank you very much for attending and for all the great questions.